Okay, moving right along with problem number 31 and 32. We've got x is an equivalence relation that we're checking on y, or it's related to y, in R, if absolute value of x is equal to the absolute value of y. Once again, starting with checking the see if it's reflexive or not. Well, that would be, let's just use absolute value of a equal to the absolute value of a. Check. Yes, it is. These are pretty easy here. Is it symmetric? Is the absolute value of a equal to the absolute value of b? If this is true, then is absolute value of b equal to the absolute value of a true? Well, if this is true, yes, that is true also. By proof of this equal sign, yeah. Okay, transitive. Is this transitive? That means if you have a is equal to b, and you have b is equal to the absolute value of c, then that implies that the absolute value of a is equal to the absolute value of c. Well, is this true? Everything is equal. If you have these two, yes, absolute value of a will be equal to the absolute value of c. Check. We can just move on from there. Now, so yes, this is an equivalence relation. Equivalence relation. But the problem is also asking us about the partitions. It says, describe the partition arising from each equivalence relation. So this is an equivalence relation. Well, what is this partition? If you have an equivalence relation, you're going to get these partitions that are kind of unique to themselves. For example, in this one right here, if you have the absolute value of 0 equal to the absolute value of 0, this is one single entity. How can I say this? Hard to describe. You denote each partition from an equivalence relation with a bar on it, and then you just list the elements that would be in it. For this equivalence, for this partition here, for 0, you would just list the element 0. The other partition is pretty much everything that doesn't contain 0. So let's just call that A again. So this partition A is equal to, well, what's working here? We got negative A and A of all the real numbers. So as long as the numbers are the same, this holds. I mean, this is the collection of all the paired numbers in which, let's see, A, absolute value of A is equal to absolute value of A. We've got absolute value of negative A is equal to the absolute value of negative A, and any combination of these two. So either absolute value of A is equal to the absolute value of negative A. So all of this is partitioned, and when you combine it with the 0, then you get your original group back, which would be all of the real numbers. Okay, going to 32. What does 32 say? 32, x related to y in the real numbers, and if the absolute value of x minus y is less than or equal to 3. Let's start checking the properties. Is it reflexive? Well, let's see. We would have a minus a less than or equal to 3. Well, a minus a, this is basically the additive inverse. So this would be 0 is less than or equal to 3 for the real numbers. So that checks. 2, is it symmetric? Is it symmetric? Okay, that means if we have a minus b, absolute value is less than or equal to 3, then the absolute value of b minus a is less than or equal to 3. And of course, just looking at this is a difference between two numbers. It's either going to be negative or positive, but your absolute value signs right here, they're always going to make it positive. So this difference and this difference, the magnitudes are identical. Now they may be negative or positive, implying a different direction. So this is actually going to be true. Now, here's where I think things might get a little bit hairy. Is it transitive? So what does that mean? That means if you have a minus b absolute value is less than or equal to 3, and you also have that b minus c absolute value is less than or equal to 3. If you have those, then you automatically get that the absolute value of a minus c is less than or equal to 3. Let's play around with a few numbers and see if this is going to work. And let's let a equal 2. And you always want to pick a 0 just for fun. And since b happens to be in both of these, your original hypothesis, let's go ahead and make b 0. And then we'll let c equal negative 2 maybe. So you got to go in and mess with some numbers. Well, let's see what happens here. We've got absolute value of 2 minus 0 is less than or equal to 3. That's true. 2 is less than 3. And b, 0 minus negative 2, absolute value is less than or equal to 3. Well, this is 2 again. This checks out, so these numbers give us a true hypothesis. Now all we have to do is check to see if this still holds. So a is 2 minus b was 0. Oh, actually we're trying to get c, negative 2 minus negative 2. Well, less than or equal to 3? Hold it, this is 4. Absolute value of 4 is less than or equal to 3. This is not true, hence number 32 is not an equivalence relation. And that's the end of that problem.